Suppose we want to make a rectangle class and say a circle class. A rectangle has an area, a perimeter, a length, and a width. A circle has an area, a perimeter. It's basically the same thing. It's technically a circumference, but it's the same thing. And then afterward, a radius. Like that. Now notice that the rectangle and circle class both have area and perimeter methods. So basically we can have them both extend, for example, say shape, where a shape contains the area method and the perimeter method. That way we know that any object of type shape has an area and a perimeter method. And then we run into a problem, which is that how do we implement the shape's area and perimeter methods? For example, let's just say we create a class shape right here, and then public double area and public double perimeter. How would I implement these? I could give false values, but that could sometimes cause problems. Therefore, instead, we can do something called making these methods abstract methods. So basically, first we need to make this class an abstract class, which means that now I cannot create an instance of shape. And now I can make, say, area and perimeter both abstract. So public abstract double area and public abstract double perimeter, and then just semicolons at the end of the header. So what is an abstract method? It's basically just a method that literally has no body and we don't know what to do, but the subclass should know what to do. So basically, for example, rectangle we should be able to easily make an area and perimeter method, basically override these. In general, first of all, abstract methods must be in abstract classes. So we cannot have an abstract method in a normal class. Second, abstract methods have no body. And third, abstract methods must be overridden in non-abstract subclasses. Or basically, logically, basically subclasses, say a class rectangle. If we make rectangle extend shape, then this won't work. Why is that? Well, this is because rectangle basically inherits everything from shape, right? So it inherits two abstract methods. However, we just said that abstract methods must be in abstract classes. Rectangle is not abstract. So therefore, it must override both the area and perimeter methods. Like that. Now, why can't we create objects of type shape then directly? So why can't we do this? Well, there's a reason. It's because shape has two abstract methods, like right here. So if this were allowed, then what would sh1.area return? That just simply wouldn't work, right? Because we don't even have an implementation. So therefore, we cannot create objects of an abstract class type. Instead, we create their objects of their subclass type. So for example, a rectangle, or even a shape, but that is set to a rectangle. And now the area and perimeter methods will work because they're overridden in the subclass with some potential rounding errors. Another example, the circle, like that. Again, circle must override the area and perimeter methods. Now, when do we not need to override abstract methods? Well, it turns out if we have an abstract class, say special shape that extends shape, it automatically inherits the abstract methods area and perimeter. But since this is an abstract class, I'm allowed to keep them as abstract methods, basically not override them. And in fact, I can basically put additional stuff. And here we go. We have an abstract class that does not override abstract methods from its superclass. Now, notice that we have a constructor in this abstract class. That does not mean that we can create objects of type special shape. If we try that, then that won't work. The only reason we have this constructor is so that subclasses can use them. So basically, class special rectangle extends special shape, and then super of n, and that's the only use of this constructor. Basically, you can call super and it'll set the name, and then length equals L, width equals W. Now, this may appear to work, but we forgot something. Remember that special shape extends shape, which means that it inherits abstract methods area and perimeter. Therefore, we need to override the area and perimeter methods, since special rectangle is not an abstract class. So public double area, again, just return length times width, public double perimeter, return the perimeter, and then it'll work. So now we can do stuff like this, and I can still call the area method, because we know that although we don't have an implementation of area for shape, we know that for any object that this shape variable can be, we know that there is an area method. So therefore, we're allowed to do sh3.area, which shows the usefulness of abstract classes. Another nice thing about these abstract classes is that we get to make an array. So for example, I can put a rectangle in there, a circle, and even say a special rectangle and something like that. So we can have something like this, which is pretty nice. Also, for example, now we can do stuff like this. A method that takes a shape array and returns the total area of all shapes. So for example, public static double total area that takes in a shape array. Assume that none of them are null for now, and then we can just do, for example, we keep track of the total, and basically for every shape in the shape array, I can do something like, for example, result plus equals s dot area, and then return result. And then now if I print total area of the shape ARR, it's gonna be this number, basically 35 plus 16 pi plus 20, which totals to around 105. Now, imagine what would happen if I didn't have my abstract area method right here. What happens if we don't have that? Well, now all of a sudden, let's see. Okay, let's ignore all of the errors in the main method for now. And let's focus on the errors in the total area method. Result plus equals s dot area. So, because now shape does not have an area method, now shape, basically we cannot do s dot area because s is of type shape. Shape does not have an area method. So potentially there could be something that extends shape that doesn't have the area method. Therefore, Java, to be safe, restricts this. So then therefore, what would we need to do? We would need to do the following. If s instance of rectangle, then result plus equals s, a rectangle s dot area, and then if s, so else if s instance of circle, result plus equals circle s dot area. And since technically special rectangle doesn't extend rectangle, we need to do if s instance of, say, special rectangle result plus equals special rectangle. S dot area. And that would work. However, notice that we needed like so many ifs. And for example, if we make like a triangle class, we need another if. If we make a hexagon class, we need another if. And for more shapes, we need more ifs. And that's just bad. So therefore, why not just have shape instead have the area method so that we're able to just do s.area without casting. So that is where, and that is a big use of abstract methods. Another thing is that basically abstract classes don't have to have abstract methods. There's not a lot of point to having these abstract classes. I mean, they can be useful, but basically just be aware that abstract classes do not need abstract methods, even though abstract methods need to be in abstract classes. Another thing, we know that normal classes can extend both normal classes and abstract classes, like rectangle extends shape. Now, can abstract classes extend abstract classes? Yes, we saw that special shape extends shape. Can abstract classes extend normal classes? It turns out yes. In particular, for example, shape extends object, or A also extends object. Basically, abstract classes can extend regular classes.